Assalamualaikum warahmatullahi wabarakatuh. Remember that in chapter 2 you have learned about the idea of conditional probability. Well, let's say you have probability A given B. In this case, B has already happened, so we can supply the information right here at the bottom. We can find what's the probability of B. And at the top part here we have the probability of A intersects with B. So that's the formula to find conditional probability. And in this video I'm going to talk about more or less the same idea, and here is about the conditional distribution if you have discrete random variables, and another term is conditional density if the random variables we're talking about are continuous. So right here is, again, it is natural that if you have two random variables, let's say x and y, you can see that in order to describe them together, we can use the mathematical notation here. So this is fxy here can represent either the joint probability mass function or the joint probability density, depending on whether those random variables are continuous or discrete. I'm sorry, the other way around, depending on whether x and y are discrete or continuous. And in the previous video we have seen that this joint probability distribution or joint probability density, they can be separated if you're interested to study just x alone or y alone. And if you want to be more specific or you want to differentiate between one another, you can use a different notation. For example, you can represent this with gx and this one with hy. So those are called the marginal distribution or marginal density. And again, it is also natural that when you have more than one random variable, then you may be interested in distribution of x given y or vice versa. Okay, so either x given y or y given x, and those are called the conditional distribution if it is a discrete case, or it is called the conditional density if you talk about the continuous case. So therefore, what we have right now is a broad mathematical expression. So here we have what is known as fx given y. So this part here, it can be either continuous or discrete. And this part here is the joint probability distribution, or it can also be the joint density. Okay, depends on whether you're talking about discrete or continuous case. And again, following the same idea as the conditional probability which you have seen in chapter 2, we're going to supply the information right here at the bottom related to y. So here we have the marginal distribution, okay, or the marginal density, okay. And the formula to get the marginal distribution or marginal density have already been covered in the previous video. So right now in this video, I'm going to just give an example related to finding the conditional distribution for discrete case, and then in the next video I will be talking about an example of continuous case. Okay, right, so here is an example where this example is related to example 3.9. Well, if you don't recall what is example 3.9, this is a specific example where you are asked to create the table for fxy, where your x here is the random variable that represents the number of aspirin, and y represents the number of sedative. Okay, and this is the result that you have seen in example 3.9. And then in example 3.15, we have looked at how you can find the marginal distribution for x and the marginal distribution for y. So this one is in example 3.15 and this is in example 3.9. Now in this video we are going to look at how you can find the conditional distribution of y given conditional distribution of x given y is equal to 1. So what it means really is we are interested to find what is fx given y is equal to 1. Okay, so now again what we need to think about is we need to think about what are the values that x can take. So you can see that based on example 3.9 right here, or based on the result of marginal distribution for x can take the value of 0, 1 and 2, and we're going to consider that one by one. Okay, so right now is this is what we are looking for. This is what we are looking for, and now we're going to start considering what happens when x is equal to 0. Okay, so when x is equal to 0, what we have is f0 given y is equal to 1, right? So I'm just changing this part accordingly, and according to the formula, what we have is we're going to have f, this part here is xy, right? Xy, which looks like this. Okay, sorry, like this. Okay, this is the formula. Okay, we're going to just follow the notation right here. Okay, so what we have is actually xy is the combination of x and y. I'm just going to write down what's the combination straight away. So the combination is 0 and 1. So this is the combination. Okay, and at the bottom part here is the result here when we have y equals to 1. And the answers can be found straight from the table. f01 means you are looking at x0 and y1, which is this value here. So this is 16 over 72. And then at the bottom part here, we want to find the marginal distribution for y, and when y is equal to 1. So this is the result. When y is equal to 1, the result is 28 over 72. And we can cancel 72 with 72. So 16 over 28. And that can be further simplified to 4 over 7. And this is the answer given for the first part. Okay. Now let's move on to the next one, where you have to consider the next value of possible x. So you can see the next value of possible x here is x equals to 1. Okay, so when x is equal to 1, what we have is f1 given y is equal to 1. So I'm just again following this general formula related to finding the conditional distribution of x given y equals to 1. And right now at the top part, we're going to consider the combination of x and y. So the combination of x and y is going to be 1 and 1 in this case, because y is equal to 1 and x is also equal to 1. And at the bottom part, we're going to supply the information related to y equals to 1. So in other words, we have to, if you don't have a marginal distribution for y, you need to find that first. But fortunately, we have already done that in example 3.15. So we can just straight away get the answer right there. Okay, so when y is equal to 1, the answer is again 28 over 72. And at the top part here, 1 and 1 is referring to this value. Okay, 12 over 72. This one is over 28 over 72. Again, this one can be cancelled out. So you have 12 over 28, which can be simplified to 3 over 7. And so this is what you got right here. And finally, let's look at the last one. So last one is we need to consider what happens when x is equal to 2. Okay, so here we have when x is equal to 2, then we have f2 given y is equal to 1. And again, at the top part here will be the combination of x and y together. So we have to consider the joint probability distribution between x and y. So x is equal to 2, y is equal to 1. And at the bottom part, we will supply the information related to y equals to 1. So in this case, we are looking at the marginal distribution of y when y is equal to 1. So when we look at this table right here, 2 and 1 refers to this value, so that is 0. The marginal distribution for y equals to 1 is this one, so 28 over 72, and therefore the final answer for this one is equal to 0. So the conditional distribution of x given y is equal to 1 can be represented as such, or if you want, you can also come up with a table. For example, you can write down this in terms of a table. You can list down x is equal to 0, 1, and 2, and at this part here, we're going to consider the conditional distribution of x given y is equal to 1, and you can write down the result as 4 over 7, 3 over 7, and 0. And just note that if you total out the values here in the table, it should be equal to 1. Okay. Alright, that's all for now related to the idea of conditional distribution for a discrete case. I will continue in the next video with example related to continuous case. Thank you very much for watching.